Hello everyone, welcome to the video lecture series of data structure. Our today's topic is circular queue insertion and deletion. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, first today we are going to learn about the concept of the circular queue. Then we'll see the circular queue insertion and circular queue deletion. So first, let's learn that what do we mean by circular queue and why the circular queue is needed. So, circular queue is nothing but a linear data structure in which the operation of insertion and deletion occurs two different times, same as the simple queue. It follows the FIFO manner, but here the last position is connected back to its first position. That's why it is known as circular queue. Here, if you can see, this is a circular queue where our the front pointer and the rear pointers are also there. But see, this is just a representation of a queue in a circular manner. Actually, in data or in a memory, the queue is not like in this circular queue manner. Okay, this is just a representation of circular queue, that how the last data element is connected with the first data element. Fine. Now, unlike the simple queue, what happens when we talk about the simple queue? Students, just imagine a situation that in a simple queue, your queue has only one element at the rear end, or the only one element at the rear end. That means at the fifth position. All the fourth, one, two, three, four, all the four positions are empty. Now, if you want to insert something in the queue, can you insert in simple queue? Yes or no? No. Why? Because my rear pointer is at fifth position. Although my OR four positions data like 1, 2, 3, 4 are emptied, but I cannot insert my value over there because according to the rule, this is a simple queue, cannot move directly from the last position to the first and make it circle. So this is the disadvantage of a simple queue. That's why we come up with a circular queue concept. So the very first, the bicircular queue, again, let me show you. This is a simple queue where you cannot insert element even after the removing the two elements. See, this is my simple queue. If I want to remove something, I cannot insert the new elements over there because my queue is still gets full. That's why to solve this, we come up with the idea of circular queue. Next, let's talk about the circular queue insertion. Once again, let me remind you here in our each and every algorithm, our array index starts from 1. Okay. So, unlike the simple queue, students, what happens over here? In circular queue, you always, during the insertion, we need to check the overflow condition. Yes, you are correct. But we are going to check the overflow condition later after checking the position of the rear pointer. That step is also known as the reset rear pointer. Okay, how? Let me show you. Students, this is what is this? This is a queue insertion, circular queue insertion. That means you are not going to remove anything, you are not going to return anything. That's why it's a procedure. Okay, the name of the procedure is CQ delete. Here we have R, F, Y, Q, and N. So QFR shows Q shows the Q, F shows the front pointer, R shows the rear pointer, Y the element which is going to be inserted over here, N is the size of the queue. Fine. So let's check out the first. So here the first position is the first step is that if your rear pointer is pointing at N. Now what happens in simple queue? If my rear pointer is pointing at last position, that means N, then what I need to do, I just need to write that my queue is overflow. You cannot move further. Okay. But here my rear pointer is, if my rear pointer is at N, that means at last position, then we need to move towards the first one. If my rear pointer is at last position, then we need to move at the first one. Then and then it will become a circular. So let me check. If my rear pointer is at N, then you should go R arrow 1, else you should write R arrow R plus 1. Fine. So if my rear pointer is pointing to the end position, then my rear must be at 1, else you just need to increment the rear pointer. Now, after incrementing the rear pointer, you need to check the position of front and rear. So students, just imagine a situation that where you have a circular cube. Okay, at the time the front and rear pointers are also there. What you need to do is you just need to understand that if my front pointer is at first position and here is at n, okay, that means your queue is full. Your queue is full because your front pointer is at first position and rear pointer is at n. Okay, now if I want to insert more elements, then according to the condition, I need to check whether my rear pointer is n or not. Yes, it is at n. Then I need to move it at 1. Now see, 1. Front is already at 1, rear is also come at 1. So 1 and 1, both point positions are same. So after during the insertion in circular cube, remember the statement, during the insertion in circular cube, if after resetting the value of r, your front and rear becomes at the same position, that means your cube becomes overflow. Fine. So if my f is equal to r, then you can write the q is overflow and return. You cannot move ahead. Your algorithm is over. If it's not like that, then you can insert a new element. How? The same process as a simple q. Just need to assign y to q of r. Then check whether my front pointer is 0 or not. Yes, it's same as the previous one. Because if your queue is empty, then the front and rear both pointer position at 0. Okay, so when you assign the value to r, at least one element is there. So when you assign a value to r, at least one element is there. So you also need to move f over here. Okay, so f and r at the same position after inserting, not during the insertion. Fine. So this is the situation. If my f is equal to 0, then you just need to move f towards 1, then return. So that's all about the first algorithm of circular queue insertion. Let's check out the example of it. So here, this is just an example queue, that this is how your queue looks like. Let's understand it better. See, here my front and rear. Here if you can check out the table, you can see my front position is at 1 and rear is at 2 and value is 30. If I am incrementing it, then rear becomes 3 and value becomes 40. So such like this you can move ahead. Let's understand it better in circular queue insertion example. Same as the previous one, here circular queue, my front and rear both position at 0. Now if I want to insert something, then what happens? See, if this is my first situation, circular is just a representation. These type of queues are not exist in a memory, but this is just a representation. This is how you can represent your circular queue. Okay, so this is my circular queue. My front and rear both are at 0. Now if I want to insert something, then what happens? See, insert 10. Insert 10. That means the rear value goes at 1. What happens, students? Here if you can see, my front and rear both are pointing to at 1, because I'm going to insert 10. So after inserting 10, front and rear are both pointing at the same position. Now let me insert 20 in this queue. So just check out the steps. Just open your notebook, check out the steps that I have written over in the previous slide. So what happens? During the insertion of 20, first you need to check whether your r is at n or not. Is that so? No. So just need to increment a rear pointer. Now rear value becomes 2. Rear value becomes 2. Now check whether my f and r both at the same position. No, because f is at 1. Rear latest value of rear is 2. Okay, after incrementing, the latest value of the rear is 2. So what to do? You just, the condition becomes false. Move towards the step number 3, where you have written over there that q of r arrow y. Q of r arrow y. So you just need to insert the new element to the rear position. Now the new rear position is 2, so I am going to insert the 20 over there and then check whether f is at 0 or not. Is f at 0? No. So just leave it as is. That's how you can insert element in Q. Now the next, again, the same process will be done for the 30. The same process will be done for the 40 also. Now what happens for the 50? If I'm going to try to insert the 50, what happens? Just check it out. Here, if you can see, my front pointer is at 1, yes. Rear is at 4, yes. Q size is 4. Size of Q is 4 only. Okay, now check. R is equal to N or not? R is equal to N or not? Yes, the condition is true. So R becomes 1. R becomes 1. Now students, let me tell you. The latest value of R becomes 1. F is at 1. Both are at same position. F is equal to R. The Q becomes overflow. Step number 2. What to do if the Q becomes overflow? Just write down return. You cannot insert 50 because F and R both at the same position. Q becomes full. This is how you can write the overflow in circular Q. Okay. So this is just an example of circular Q insertion. Now let's move towards the next algorithm, which is known as circular Q deletion. So students, again in the circular Q deletion, you can see the deletion, that means we are returning something over here. That's why it's known as a function. Again, I'm repeating this. That's why it's known as function. Okay, not a procedure. So in circular Q deletion, students, we have the function CQ delete. Parameters are Q, F, R, N. Why we need N over here? Because this is the circular Q. We used to compare the position of the front pointer to N, not rear. Because this is a deletion, students. In deletion, students, we are comparing the value of front pointer with N element. Fine. So what we need to do, we just need to compare the front with the N and check whether my Q is full, or whether the front pointer is N or not. Fine. So let's take out the very first step. So during deletion, we need to check out the underflow condition, obviously. So when the Q is empty, the Q is known as underflow. So when the Q is underflow, the front end are at 0. So you can write if the F is equal to 0, the Q is underflow. It is the same as the Q simple Q deletion. Nothing changed. Now the second number step. If students, your Q is not empty, that means you have some elements to delete. So what to do? You just need to assign Q of F value to Y. You just need to assign the Q of F value to Y. So here it is, second number step, Q of F to Y. Step number 3, that check out if the F and R at the same position or not. Students, if your F and R at same position, okay, then it becomes Q empty. So you just need to move F and R to 0. This is again same as the previous one, and just need to return Y. You just need to return the value of Y. So what's the change in the circular Q? Only one step, that is the increment of the front pointer. Here, if you are inserting in the deletion, apply the deletion in the Q. If a front pointer is at nth position, then you should move from n to 1. If it's not like that, if it is not at n position, then you just need to increment your front pointer. Fine. So here it is, the last logic. If F is equal to n, then write F arrow 1, else F is equal to F plus 1 and return Y. Here, do not forget to write return Y in 2 different steps, because if your condition is satisfied in step number 3, you are not going to move forward to step number 4. Once you write return in any algorithm or any function, the below code of the return statement will not going to be executed. Okay, always remember this. Okay, so let's move towards the example of the circular Q deletion. So the first circular Q deletion, students, here it is. The Q is emptied, then the situation is same as the previous one, but I'm not going to take empty Q for you. Okay, so let's begin with some basic Q. Here you have the 10, 20 and 33 elements are there. If you want to delete something from this Q, first I need to check whether my front pointer is at 0 or not. No, it's not at 0, it's at 1. So what you need to do, you just need to assign 10 to Y and then check whether my F and R both are same or not. But here again, my F and R both not at the same position, so need to move further. Check whether my front pointer is at n or not. Here students, my front pointer is not at n, so I just need to increment like F is equal to F plus 1. So 10 gone, F is at 20. Again the same process will be done. 20 gone, F is at 30, and then check F and R both at the same position. So when again students, when the 30 will gone, okay, check F and R at the same position. So my Q becomes empty, and again my front and R both pointing to the 0 position. So here it is. and empty queue, students, my front and rear both pointing to the 0 position. Fine. So my queue becomes empty when front and rear are at same position. Have you ever seen something, students, that in circular queue deletion, if F and R both at the same position, it is known as empty, and in circular queue insertion, when the F and R at the same position, it is known as circular queue is full. Okay, so just trace the algorithm, just write down your data and check it whether the algorithm is correct or not. Okay, let me show you one table example of here. Here the question is, you just need to write down like write down the position of front and rear pointer. After each and every operation, you just need to write down the position of front and rear pointer. Here the queue size is 6. Assume the F is at 2 and R is at 4. So just calculate it. When F is at 2 and R is at 4, okay, and if this is my queue, then we dash L M N dash dash. So you can easily get the idea. The front pointer is at 2, that means at L, and the rear pointer is at N. That means here in my queue starts from the first index. The queue starts from the first index. Fine. Now let's check out the various operations. So here are the various operations. The first, we need to make a column over there. First write down the operation, then front, then rear and the queue. If I am talking about the first operation, students, you can check out that the begin operation. The first time the front and rear at 2 and 4. Now the second operation is add O, insertion of O. Okay, so when you are inserting something, your rear pointer is incremented. It will move towards the 4 to 5. So only the change is in rear pointer position. See the second line. See the second line. The rear pointer is at 5, front is at 2, remains as it is, and the O is inserted. Next is add P. Again, front rear pointer is incremented, rear is at 6, front is at 2. Next, delete. When you apply the delete button, front is incremented. Front is incremented. So now front is, instead of 2 it becomes 3. Okay, and rear is at 6. Now, next we'll talk about the delete again. So it incremented at 4, rear is at 6. Now add Q and R. Add Q and R. See, in this queue, you already have some space at the first position. Your rear pointer is set 6. This is the circular queue. So you can directly move towards the first position. Okay. So instead of 6, it goes towards the 1 for inserting Q and again 2 for after inserting R. So this is my queue after inserting Q and R. So the position of front and rear are 4 and 2. Next is add S, add T. So it becomes 4 and 4. So now after inserting students S, what happens? The S is inserted. Now my front becomes 4, rear becomes 3. Front becomes 4, rear becomes 3 after inserting S. Now if I am trying to insert T, what happens? I'm insertion, circular queue insertion algorithm. Okay, first you need to reset the rear position. Rear is at N, no, then increment rear. What is the latest value of rear? Check at the S column. What is the latest value of the rear? That is 3. Now, after incrementing the R, it becomes 4. Front is already 4, rear becomes 4. Okay, both at the same position. That means you cannot insert any value. Okay, that means your insertion is unsuccessful. You cannot insert the T over there. Rest of the two operations are delete, are the same as the previous one. The only front pointer will be incremented and it becomes 6 and the rear is at 3 only. So such like this you need to write in the exam when they ask for the position of the front and rear. You need to make such a table, operations, front and rear, and then show the data. So that's it for the today's lecture, students. Thank you so much.